Hello all, welcome back to my YouTube channel all about VLSI. Hope you're all doing good and I hope my voice is audible and my screen is visible. Yeah, I will try to share the PPT of SystemVerilog. Yes, I will try to share it. Okay. I will upload it in the drive and I will share the link of the drive. Okay. Yeah. So I hope my voice is audible and my screen is also visible. So let us start this session. So in this session we are going to discuss about fork join and what is this fork join. Okay, threads in SystemVerilog. So let me open my presentation. Yeah, so basically the threads in SystemVerilog, the threads are processes that execute concurrently. Okay, so basically these threads execute concurrently and they are primarily used for simulation purpose only and allowing multitasks to execute independently or in synchronization with others. For example, in normal Verilog, uh, let me let me open a blank page for a minute. Okay, I will show it here only. So in normal Verilog, if we have procedural blocks like always block, if we have procedural blocks like always block or initial block, let us consider the procedural blocks like always block or initial blocks. Basically, the statements inside this always block or initial blocks, these will be executed sequentially. The statements inside this always block or initial blocks, this will be executed. The statements, the assignments inside this always block or initial blocks will be executed sequentially. Okay, in sequential manner, that is step by step. These will be the assignments inside this always block or initial blocks will be executed. Okay, sequential manner. But when we use a thread, okay, when we use a thread, we can do concurrent assignments. We can do concurrent assignments or what you can say parallel assignments. Okay, so basically these threads are used to process statements concurrently. Okay, and there are these are used only for simulation purpose only. Okay, so this is the difference why you are this is how and why you are going to use the threads. Okay, now let's see what are all the different type of threads we have. So in SystemVerilog we have different three type of threads. One is fork join, one is fork join, and another is fork join any, and another is fork join none. Okay, so first type of thread is fork join, followed by fork join any and fork join none. So to manage the threads, and this construct allows user to execute multiple tasks in parallel and determine when to proceed based on the specific conditions. Okay, so let's start with the discussion of fork join. So basically, fork join block starts multiple threads concurrently and waits for all of them to complete before proceeding to further. Okay, so this is a basic syntax for fork join. Okay, this is a basic syntax for fork join. Uh, you should write fork and join. These are the keywords followed by thread one, or you can say assignment one followed by thread two. So after completing these two assignments or this two threads, then only the compiler will get out of this fork join block. Okay, so until the completion of this fork join, the assignments which are present inside this fork join, until the completion of this thread one and thread two, the compiler will not get out of this fork join. Okay, so after the completion of all the statements written inside this fork join only, then only the compiler will get out of this fork join block. Okay, until the execution has been completed, it will not get out of this fork join block. Okay, so that is the fork join, and this thread 1 and thread 2 or these two assignments will be running parallelly or you can say concurrently. Okay, this will be running parallelly or concurrently. Okay, so this two threads will be running parallelly. Okay, this will be running concurrently. Let's take an example and analyze what is how this fork join is working. Okay, So we have taken a module called fork join underscore example, and within an initial beginning block, we have displayed something which is called as start of fork join. Okay, within an initial beginning block, I'm displaying this, and I'm using this fork, okay, and join. Okay, so this is thread 1. This particular display statement is my thread 1, and the second statement is my thread 2. Okay, so this first statement is my thread 1, and the second statement is my thread 2. So after the completion of execution of thread 1 and thread 2 only, my compiler is getting out of this fork join block. Okay, so until the end of the completion of this two threads, the compiler will be in this fork join only. Okay, now, so what is the thread 1? What it is saying, we have used a delay inter assignment delay #5 $display thread 1 executed at time, and we are displaying the time, and the thread 2 is saying that #10 $display thread 2 executed at time, and we are displaying the time. And after this fork join, we have written one more statement called $display end of the fork join. Okay, now, as we have discussed that in the previous slide, also we have discussed that this two threads will be running parallelly. Okay, these two threads will be running parallelly, that is th1 and th2 will start executing at 0 time units only, and this will be running parallelly. Okay, so if you don't use this fork join, then what happens? If you don't use this fork join construct, then what happens? Since these are declared inside this initial block, which is a procedural block, the first statement will be executed, then the next statement will be executed. Okay, since initial block is a procedural block, so it will all the statements will be executed in a sequential manner. But since you are using a fork join block, the two statements will get executed parallelly at same time. This execution will takes place, but here you are mentioning some time delay. For the first thread you are giving #5 time unit delay, and for the second thread you are giving 10 time unit delay. Okay, so what is the output finally? If you analyze, at time t is equal to 5, at time t is equal to 0, nothing will be executed, nothing will be displayed. Okay, this the outside statement of this fork join, that is $display end of the fork, will also not be displayed. Why? Because this until the statements inside this fork join are completed executing, then only the compiler will come out and it will execute this $display statement which is written outside this fork join. Okay, so after how many time units the outside display statement will be executed? So after 15 time units only, the third display statement will be executed. Okay, so at time t is equal to 0, nothing will be executed, and at time t is equal to 5, the thread 1 will be executed. So this first display statement will be executed. What we are getting? Thread 1 executed at time t is equal to 5. Okay, next, after 10 time units, at time t is equal to 10, thread 2 executed at time t is equal to 10. Okay, so these two statements has completed executing. Okay, so the two statements or two threads in this fork join has completed executing. Okay, so since the two threads has completed executing, the compiler will come out of this fork join block and it will execute the third statement, that is end of fork join at time. So here you can see end of fork join at time t is equal to 10. Okay, sorry, here it is not 15, it is not 15, it is time t is equal to 10. Since these two blocks are running parallelly, since these two threads are running parallelly, so here we will get the third output at time t is equal to 10 unit. Okay, so this is how the fork join block works. Okay, so the two threads will be running parallelly, and after completion of the execution of these two threads, the compiler will get out of this fork join and the third statement will be executed. Okay, so this is fork join and this is the syntax for fork join. Okay, now the second type of thread we have is fork join any. Okay, the first type which we have seen is fork join, normal simple fork join, and the second type is called fork join any. Now, in the case of fork join, what we have seen, until the completion of thread 1 and thread 2, the compiler is not getting out of this fork join block. Okay, until the completion of thread 1 and thread 2 completes, okay, until thread 1 and thread 2 completes their execution, the compiler is not getting out of this fork join block. But in the case of fork join any, what is happening? So if at least one thread completes its execution, at least one of the two threads completes their execution, the compiler will get out of this fork join any. Okay, so if any of the thread has completed its execution, the compiler will get out of this fork join any. Okay, so that is what it is written here. So the fork join any block starts multiple threads concurrently. So this two threads will start their execution concurrently or parallelly. Okay, so if thread 1 has completed its execution successfully, then the compiler will get out of this fork join any and it will execute the statement which is written outside this fork join any. Okay, so the fork join any block starts multiple threads concurrently but waits for only one thread. Okay, so here fork join any waits for only one thread to complete before proceeding, whereas in case of fork join, here there are two threads, so the fork join block will wait for the completion of execution of these two threads, whereas in the case of fork join any, it will only wait for one thread. Okay, it will only wait for one thread to complete the execution. After the completion of that execution, the compiler will get out of this particular block. Okay, let's see an example here. Let's take a module called fork join any underscore example, and we are displaying $display start of fork join any and fork #5 $display thread 1 executed at time t is equal to some time, and #10 $display thread 2 executed at time t, and after this we have written $display end of fork join any at time t. Okay, now let us see the output what we are getting. So this first display statement we are getting start of fork join any. Now the first thread will complete its execution at time t is equal to 5. Here if you observe the delay, what it is written, 5 time unit. So the first thread will complete the execution at time t is equal to 5. So at time t is equal to 5, the first thread will be displayed. Okay, it will complete its execution. So since we are using the construct fork join any, here you can see we are using fork join any. Since we are using fork join any construct, so since it will only wait for the completion of one thread execution, so it will come out of this particular block and it will execute this outside statement, that is $display end of fork join any. Okay, so here at the output you can see end of fork join any at time t is equal to 5. Okay, since the fork join any block will only wait for the completion of only one thread execution, so after only one thread execution, it will come out of the fork join any block. Okay, and that doesn't mean that it will not go back to the fork join any block. Okay, so it will come out, the compiler will come out and of this fork join any, and it will display the statement which is declared outside the fork join any block, and it will go back and it will check for the incomplete thread completion. Okay, incomplete thread execution. So since there is one more thread, so it will be displayed at time t is equal to 10. So first what happens, first at time t is equal to 5, thread 1 will be executed and the compiler will get out of this fork join any block and this particular display statement will be executed, and at time t is equal to 10, thread 2 will be executed. At the output you can see. Whereas in the case of fork join, what is happening, first at time t is equal to 5, thread 1 will be executed, and at time t is equal to 10, thread 2 will be executed, and afterwards your display statement which is declared outside, that will be executed. But in the case of fork join any, what is happening, first at time t is equal to 5, thread 1 will be executed and the compiler will get out of this block and the outside display statement is executing, and after that thread 2 is being executed. So like this the fork join any works. So this is the working of fork join any. This is the working of fork join any block. Okay, now we have one more type of block which is known as fork join none. Okay, the name itself indicates that It is not waiting for the completion of any of the thread. Okay, unlike the fork join and fork join any, the fork join none is not going to wait for the completion of any thread execution. Okay, fork join none block starts multiple threads concurrently and immediately proceeds without waiting for any thread to complete. Okay, it is not going to wait for the completion of any thread. Okay, so it is all the threads will start executing concurrently only, same as fork join and fork join any, but here it is not going to wait for any completion of any thread. Okay, let's see an example here. And the syntax for fork join none is this: fork followed by thread 1, thread 2. This will be executed concurrently only, and followed by join underscore none. Okay, let us see an example, the same example, but we have used the fork join none here. Okay, now what is happening here? Same initial begin $display start of fork join none, and #5 $display thread 1 executed at time. Okay, and #10, wait a minute, yeah, #10 $display thread 2 executed at time t is equal to %t comma $time join underscore none $display end of fork join underscore none at time t. Okay, so this is what we have written, and let's see the output. So at the output you can see start of fork join underscore none, the first display statement which we have written here, right, that will be executed. And here the compiler is not waiting for the completion of these two threads. This first thread will be executed at t is equal to 5, and the second thread will be executed at t is equal to 10, and this outside will be okay. So the compiler is not waiting for 5 time units, okay, or the compiler is not waiting for 10 time units. That is, it is not waiting for the completion of execution of thread 1 and thread 2. Okay, it is directly moving outside the fork join underscore none block. Here if you see the output, you can see you are directly getting end of fork join none at time t is equal to 0. At time t is equal to 0 only, what you are getting? You are getting the display statement which is outside the fork join none. Okay, the display statement which is declared outside the fork join none, that is you are getting end of fork join none. And afterwards at time t is equal to 5 time units, you are getting thread 1 executed at t is equal to 5 and thread 2 executed at t is equal to 10. Okay, so this is the use case of fork join none. So basically you can observe one thing, that fork join and fork join any are acting like blocking statements. Okay, here you can observe the behavior that fork join and fork join any are acting as blocking statements. These are acting similar to blocking assignments, whereas fork join none is acting as non-blocking statement, whereas here the fork join none is acting as a non-blocking assignment or statement. Okay, so these are the three type of threads we have in SystemVerilog. Okay, one is fork join, and another is fork join any, and followed by fork join none. Okay, so let us summarize all these three threads. So fork join, all three threads execute concurrently, and in fork join any also all three threads will be executed concurrently, and fork join none also all three threads will be executed concurrently. And when does it proceed after all three threads finish. Okay, in the case of fork join, all the three threads complete, or all how many threads are declared inside this fork join block, until all the threads completed their execution, it will not come out of that particular fork join. Whereas in the case of fork join any, proceed after any one of the thread finishes. Okay, fork join any waits for at least completion of at least one thread. Okay, whereas in the case of fork join none, proceeds immediately without waiting. Okay, it is not going to wait for the execution or the completion of the thread. Okay, so these are all the threads we have in SystemVerilog: fork join any, and fork join none. Okay, yeah, so that's all for this session. So if you are having any doubts or queries, you can stay and ask me, or else we can end this session. I hope you have got a clear idea about what is meant by fork join any, and fork join none. Okay, so that's all for this session. So if you like this video, please like, share and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.